Hello students, welcome to my YouTube channel Fun with Chem. In this video, I'm going to discuss the structured essay part of 2024 June Unit 2 paper. So we see the 16th one. This question is about the reactions of halogenoalkanes. When halogenoalkanes are heated with potassium hydroxide, the products depend on the conditions. State what condition other than a suitable temperature and concentration that would give a higher yield of, to get a double bond from potassium hydroxide, it should be in the alcoholic or ethanolic medium. So you can write alcoholic medium. Give the type of reaction. So we can see, children, chlorobutane means, 2-chlorobutane means on the second carbon you have to have a chlorine atom, and this is the structure. So when you add ethanolic KOH, HCl will remove. If it removes like this, you get but1ene, CH2, CH3. If it removes the other way, right, I'll use another color to show that. If it is removed like this, then you get CH3, CH, CH, CH3. This is but2ene. So we can see HCl molecule has eliminated. So we can call it as elimination. State what condition other than a suitable temperature and concentration to get an alcohol. To get an alcohol from a halogenoalkane, children, we need to add in aqueous medium, right? So you can write aqueous solution. Complete the mechanism for the reaction to form butanol. So when they ask you to draw the mechanism, children, remember that always the reaction should start from the polar bond. We know there is a big electronegative difference between CCl bond, as chlorine is more electronegative. And the more electronegative one will take the bond pair electrons towards its side. And they will give marks for drawing the lone pair on the nucleophile. Then you have to show that nucleophile will attack the partial positive carbon atom. This is how we have to draw the arrows. So they have given marks like this in the marking scheme. Lone pair on oxygen of OH. For this, you get one, they have mentioned 4, half each, half mark for that. Dipole on CCl, half mark. Curly arrow from lone pair on oxygen to carbon of CCl. So this should be for carbon. They have mentioned this one. And a curly arrow from CCl bond to Cl or just beyond. So I have marked all 4 points. Therefore, you have to get 2 marks. Give 2 reasons why, under the conditions used in B2, the reaction between potassium hydroxide and 2-iodo-2-methylpropane is faster than the reaction between potassium hydroxide and 1-chlorobutane. So if I draw the structure, children, 2-iodo-2-methylpropane means, you can see it's a tertiary halogenoalkane. So when you have a tertiary halogenoalkane, we can easily remove iodine because it forms a stable carbocation, or tertiary carbocation is more stable. And also it mentioned that Ci bond is weaker than CCl bond. Therefore, we need to give only less energy to break Ci bond than CCl. So we'll see what is given in the marking scheme. First thing, you had mentioned that 2-iodo-2-methylpropane is a tertiary halogenoalkane. 1 mark for writing that. Second mark, they have given Ci bond is weaker than CCl bond. Or for the same one, for the previous one, if you mention that it forms a tertiary carbocation, or tertiary carbocation is more stable than the primary carbocation, that part is also okay for the first one. Second one, there's only one option. Ci bond is weaker than CCl bond. Then the 17th one, Find the endpoint volume and the maximum temperature by adding appropriate lines of best fit. So they have already marked everything. We need to draw the lines only. So I can draw a straight line of the best fit like this. Right, then roughly I'm getting like 27.6 for the maximum temperature, 27.6. Then for the volume, it's 21 cubic centimeters. Okay, so we'll see what they ask in this. Endpoint volume, that is 21. Maximum temperature, that is 27.6. So they have given 21 plus or minus 0.5. You can write 21.5 or 20.5. That is the range. And for maximum temperature, 27.6 plus or minus 0.1. That means you can write 27.5 and 27.7. That's the range. Calculate the number of moles of ammonia added at the end point. Okay, to do this, we have to find what information they have given. Ammonia they have given, and the volume of ammonia we found from the graph as 27.6. So if you know the concentration and the volume, we can easily find the number of moles of ammonia in 1000 into 21. 21 is the volume. Then when you find it in 1000, 1.3 into 21, it is 0.0273 moles of ammonia. The reaction occurs is shown. Calculate the enthalpy change of neutralization. Okay, so for that we have to apply Q equals to mc delta T. Now they haven't given the mass of anything, but they have given the volume of ethanoic acid. So Q is equal to mc delta T. We have to take the volume of ethanoic acid as equal to the mass of the solution, considering the density of ethanoic acid is equal to 1. So 30 into 4.2 into temperature change, you have to subtract 27.6 minus 20.7, which is 6.9. And also we are adding, not only 30, we added 21 ammonia also, right? 30 from ethanoic acid, and from the graph we found the volume of ammonia. So altogether mass will be 51, and this is 6.9. So when you find the answer, you are getting it as 1470.9 joules. When finding the enthalpy, Q over N, and Q should be in kilojoules. 1.479 kilojoules divided by the number of moles of ammonia, which is 0.20273. So you get the answer as minus 53.9 kilojoules per mole. Minus because final or maximum temperature is greater than the initial one. Then we'll see the next one. Chlorine dioxide. So you have to complete the dot cross diagram. Chlorine has 7 electrons in the outermost shell. So we can see a double bond is forming and a single bond is forming. So 1, 2, 3, 4, 5, 6. So there should be 6. Then definitely this should be a dative bond. Then only chlorine has 7 electrons. 1, 2, 3, 4, 5, 6, 7. Then this has 2, 3, 4, 5, 6. Then this will have all 6 electrons in the outermost shell. So by counting the number of electrons of chlorine, we were able to identify the dative covalent bond. Give a reason why chlorine dioxide is not a linear molecule, because you can see there's a lone pair, right? So you can mention chlorine has lone pair of electrons in its outer shell which repel the bonding pairs. Chlorine dioxide can be made from potassium chlorate in a two-step process. Potassium chloride reacts with concentrated sulfuric acid to form compound A. State the meaning of the Roman numerals in chlorate 5 and chlorate 6. That means to indicate the oxidation number of chlorine in the compound. So the oxidation number of chlorine in chlorate is +5. You can write like that also. And in chlorate 7 is +7. State the oxidation number of chlorine in chlorine dioxide. So it should be +4 because ClO2 x plus -4 is equal to 0, x is equal to +4. In step 2, compound A undergoes disproportionation. So compound A is potassium chloride reacts with concentrated sulfuric acid to form compound A. Chlorine dioxide. So when you have KClO3 with H2SO4, to form compound A. That we don't know, but we know KClO4 is there and another compound. Compound A then undergoes disproportional reaction with HClO4. Okay, what is the question they ask? In step 2, compound A undergoes disproportionation. Deduce the possible range of oxidation number for the chlorine in compound A. Justify your answer. So we know chlorine dioxide and HClO4 is forming. So this is +4 and this will be +7. So you can write should be between +4 to +7. So you can write +5 or +6. This is how you have to get. 2 marks are given for writing +5 or +6. And the reason is it should be between +4 and +7. Compound A has molar mass of 84.5 and a composition of mass. Deduce the remainder in oxygen. Okay, so now only we are going to find compound A. So first we can easily find the percentage of oxygen. From 100, subtract 1.18 and 42.01. Then you get the percentage of oxygen as 56.81. Then we can work out the empirical formula. H is there, Cl and oxygen. For hydrogen 1.18, 42.01 and 56.81. Divide by 1, divide by 35.5 and divide by 16. So you get 1.18, 1.183. This is 3. So divide by the smallest decimal number. Sorry, you are getting 3.550. So smallest decimal number is this. Then you get 1 to 1 to 3. So it is HClO3. That is the compound. Write an equation for each of the 2 steps in the formation of chlorine dioxide using an answer in B. So if you didn't get it correctly, both will be wrong. So we know potassium chlorate is KClO3 with H2SO4 will give HClO3. Then HClO3 and K2SO4 will react with that will undergo disproportionation to give HClO4 and ClO2. To balance it, you have to put 2 here and 2 there. And for this, you can write the half reactions. HClO4, this is +7 and this is +5. Then only both charges will balance. Then I need to put water molecule this side and 2 H plus. This is +5 and this is +7 and 2 electrons. If you take the other one, ClO2 +4 +5. Then I need to add one water molecule to this side, 2H plus 1E. Then I have to multiply the whole equation by 2 to equal the number of electrons. Then 2, 4 will cancel out, 2H will remain, one water will remain, electrons will cancel out. So 2 and 1, I will get 3 HClO3, 2 ClO2, water, and HClO4. So this is the balanced equation. If it's a disproportionation or if it is a redox reaction, we can use the half reaction method to balance them. In this, name the catalyst. So we know we are using phosphoric acid or sulfuric acid. Under these conditions, the conversion of ethene to ethanol is 5%. Overall, okay, so here the reaction is cooled so that ethanol condenses. 1 mark is given for that. The unused ethene can be recycled. That's how you can increase the percentage. The temperature used is 300 and pressure is 7 megapascal. Compromise. So now this is an exothermic reaction, children. So in an exothermic reaction, if you increase the temperature, more reactants only will be formed. But if you decrease the temperature, rate of reaction will decrease. Therefore, we need to maintain a compromised temperature. So in the marking scheme, they have given the forward reaction is exothermic, so it is favored by a lower temperature. But the lower temperature results in a rate of reaction that is too slow. So those are the two answers they have given. Explain why a manufacturer might suggest a pressure of greater than the compromised pressure of 7 megapascal. So if you look at the reaction, children, we can see 2 moles are on the reactant side and only 1 mole on the product side. So when you increase the pressure, definitely more products will be formed. So that's the reason. So to mention, the equilibrium shift giving a greater yield of ethanol if the pressure is increased, as there are fewer moles on the products on the right hand side than the left hand side. At pressures greater than 7 megapascal, a waxy solid forms which melts over a range of temperature. So that is polythene, because we have ethene molecules. Give one other reason for not operating. So to maintain high pressures, it's very expensive, or we need a special plant, or we need equipments to withstand the high pressure, which are expensive. Increasing the amount of water without changing the pressure might also be suggested. So when you increase the amount of water, we can see that water is a reactant. So when the reactant increases, products will be formed. So it is an advantage. We can write it pushes the equilibrium to the right hand side, increasing the yield. Disadvantage is water should be condensed, or if it reacts with alcohol, because water mixes or can dissolve in alcohol. So the separation is difficult because both can form hydrogen bonding. That is the disadvantage. Then we'll see the last one. Give the IUPAC name of isoprene. So we can see 1, 2, 3, 4. So I can write it as, sorry, there's a branch chain here. So I have to give the priority for the carbon. So 2-methyl buta 1,3-diene, as there are 2 double bonds. 2-methyl-buta-1,3-diene. And when you write the name, children, remember that there should be a comma between the numbers and a hyphen between a number and a letter. Methyl-buta-1,3-diene. The peaks with the highest intensity in the mass spectrum of isoprene are at 68 and 53. So if I take the molecular formula 1, 2, 3, 4, 5, C5, 1, 2, 3, 4, 5, 6, 7, 8. C5 and H8 means 12 into 5 is 60 and 8, 68. So we know it is for C5, H8 plus peak. That is for the molecular ion peak. Then if you are getting a peak at 53, find which one has removed. So 8 minus 53. 15, that is to indicate that methyl group is removed. So if you remove the methyl group from isoprene, you get it as CH2, C, CH, CH2 plus. Or you can write the molecular formula as 1, 2, 3, 4, C4, 2, 3, 4, 5, H5 plus. Both are correct. State the origins of the P, Q, and R. So P and Q, it is due to CH stretching. P is due to CH in an alkene. Q is due to CH in an alkane. R is due to the carbon-carbon double bond. You can easily use the data booklet to get the answers. Show that myrcene and limonene are terpenes by comparing the molecular formula of myrcene, limonene, and isoprene. So for that, if you take the molecular formula of myrcene and isomers means terpenes, right? So molecular formula of myrcene and limonene is C10H16 and the molecular formula of isoprene is C5H8. For writing that sentence, you get 1 mark. Then you have to mention that a molecular formula of myrcene and limonene is twice than isoprene. So because of that, they are terpenes. You can write it like that. Both myrcene and limonene can be completely hydrogenated by reaction with hydrogen. State the condition. So you need heat and nickel as the catalyst. 5-gram samples of myrcene and limonene were completely hydrogenated. Calculate the volume of hydrogen required to hydrogenate. So you can easily find the number of moles of myrcene. When you divide 5 grams by 136, you get 0.0367. For myrcene, you have 3 double bonds. It should be multiplied by 3 to find the moles of hydrogen, which is 0.1103. This is for myrcene. For limonene, you need to multiply by 2 as there are 2 double bonds. Then you get 0.07353. To find the volume required, you need to multiply by 24,000. Then for myrcene, you get the answer as 2,647.2 cubic centimeters. For limonene, you get 1,764.7 cubic centimeters. So that's how they have given 4 marks for finding the moles of both and finding the volume of both. Give the IUPAC complete. Then if myrcene is hydrogenated, you don't have the double bonds. So I'll remove them. Then you can easily tell the name. 2,6-dimethyl octane. 1, 2, 3, 4, 5, 6, 7, 8. So 2,6-dimethyl octane. Okay, the last one. 3 students were asked to carry out single chemical test to identify. Okay, so first children, if I add potassium dichromate and sulfuric acid, we can easily identify menthol and citronellal because both of them are secondary and primary alcohols, which is linalool is a tertiary alcohol. Then after identifying these two, we can add bromine water. Then citronellal will react with bromine water. In the marking scheme, they have given a potassium dichromate would go from orange to green with menthol and citronellol, but would stay the same with linalool. Menthol and citronellal are oxidized, but linalool is a tertiary alcohol which is not oxidized. That is for the second observation and the reason you have to mention. Potassium manganate would go from, or you can write bromine water also, purple to colorless or orange to colorless, because there's a double bond present in citronellal and not in menthol. Then you had mentioned PCl5 will produce misty fume with all. Then the presence of OH group can be identified as a primary, secondary, and tertiary with the 3 alcohols. So for writing that, you get all 6 marks just to compare and write the observation with the reason. Okay, that's all children I want to discuss with you all. Thank you. Like and subscribe for more videos.